Hello students, let's see the solution for grade 10 math mini test 1. The chapters in this test are polynomials, linear equation in two variable and real numbers. Section A, question number 1. If A is equal to 2 square into 3 cube into 5 to the power of 4 and B is equal to 2 cube into 3 square into 5, then the HCF of A and B is, so we find the common factors of A and B, which is 2 square into 3 square into 5, which is 180. The option is C. If one of the zeros of the quadratic polynomial x square plus 3x plus k is 2, then the value of k is, so on substituting 2 for in the place of x, we have p of 2 is equal to 2 square plus 3 into 2 plus k equal to 0, or 10 plus k equal to 0, k is equal to minus 10. Option C. Third question. The HCF of smallest two-digit number and smallest composite number is, smallest two-digit number is 10 and smallest composite digit is 4. So HCF of 4 and 10 is 2. Option A. Fourth question. Which of the following is a quadratic polynomial with zeros 5 by 3 and 0? So we can find the polynomial multiplying x into x minus 5 by 3, which can also be written as 3x into 3x minus 5. Option A. LCM of two numbers is 1200. Which of the following cannot be their HCF? So the HCF of two numbers will always be a factor of LCM. So we can see that 200, 300 and 400 are factors of 1200. So the option is 500, which is not a factor of 1200. Option B is the answer. If the system of equation 6x minus 2y equal to 3 and kx minus y equal to 2 has unique solution, then the value of k is. For unique solution, a1 by a2 should not be equal to b1 by b2, which means 6 by k should not be equal to minus 2 by minus 1, or k should not be equal to 3. So the option is B. If 17x minus 19y is equal to 53, 19x minus 17y is equal to 55, then the value of x plus y is, so if we subtract 19x minus 17y equal to 55 from 17x minus 19y equal to 53, we get minus 2x minus 2y is equal to minus 2, or x plus y equal to 1. Option is B. Assertion. The value of p for which the system of linear equation 4x plus py plus 8 equal to 0 and 2x plus 2y plus 2 equal to 0 is consistent is 4. Reason. The system of equations a1x plus b1y equal to c1 and a2x plus b2y is equal to c2 is consistent with infinitely many solutions if a1 by a2 is equal to b1 by b2 is equal to c1 by c2. So for equation to be consistent, 4 by 2 should not be equal to p by 2, as it is not equal to 8 by 2. So here p value should not take 4, whereas it is given as 4. So a assertion is false. For infinitely many solution, a1 by a2 should be equal to b1 by e2 equal to c1 by c2, which is true. So therefore D is the option. Assertion is false, but reason is true. Now we will move on to section B. In the figure, ABCD is a rectangle. Find the values of x and y. As opposite sides are equal, x plus y equal to 30 and x minus y is equal to 14 from the figure. Now, on adding both the equation, you get 2x is equal to 44 or x equal to 22. On substituting value of x in equation 1, you get y is equal to 30 minus 22, which is 8. So, the value of x is 22 centimeter and value of y is 8 centimeter. Next question, 10th one. Given root 5 is irrational, hence prove that 4 plus 3 root 5 is an irrational number. So first let us assume 4 plus 3 root 5 is a rational number. So it can be written as 4 plus 3 root 5 is equal to a by b, where a and b are coprime integers and b not equal to 0. Now 4b plus 3b root 5 is equal to a, or 3b root 5 is equal to a minus 4b, or root 5 is a minus 4b by 3b. The left hand side it is given root 5 is irrational, but in the right hand side is rational as it is operation of integers. Therefore LHS is not equal to RHS, hence our assumption that 4 plus 3 root 5 is a rational number is wrong. So by contradiction 4 plus 3 root 5 is irrational, hence proved. Question number 11, section C, 3 mark question. A quadratic polynomial x square plus 5x minus 7 has zeros alpha and beta. Find a quadratic polynomial whose zeros are alpha square and beta square. From the given polynomial, we can find sum of zeros as minus 5 and product of zeros as minus 7. For polynomial whose zeros are alpha square and beta square, sum of roots should be alpha square plus beta square, which is equal to alpha plus beta the whole square minus 2 alpha beta, which we will get it as 25 plus 14, 39. And product of roots is alpha beta the whole square, which is minus 7 the whole square, 49. So k into x square minus sum of the roots into x plus product of roots is equal to k into x square minus 39x plus 49, where k is a real number. So when k equal to 1, we get the quadratic polynomial as x square minus 39x plus 49. Question number 12, 5 mark question. The sum of 2-digit number and the number obtained by reversing the order of the digits is 165. If the digits differ by 3, find the numbers. So let us assume the units digit as x and tens digit as y. So original number will be 10y plus x and reverse number will be 10x plus y. Now sum of the reverse number and the 2-digit number is 10y plus x plus 10x plus y, and it is given as the sum as 165. So we get 11x plus 11y is equal to 165, x plus y is equal to 15. So for the case 1, let us assume x is greater than y. In that case, you will get x minus y is equal to 3, 2x is equal to 18, x is equal to 9 and y is equal to 6. So the number is 69. Case 2, when y is greater than x, y minus x is equal to 3, 2y is equal to 18, y is equal to 9 and x equal to 6. The number will become 96. So the numbers are 96 and 69. That's all, children.